Hello, everyone. Welcome again to another episode of our Python series with emphasis on consecutive wet and dry day computation. All right, so we've had two separate episodes. The first one where we generated our own NP, our own ASCII data, and then used that as a basis to understand how the consecutive wet day function works. And we saw from it that this is picking out the longest spell or the longest period of consecutive dryness or wetness. And the second aspect focused on using the same function on the tabular data and regularly tabular data, data we have in structures of rows and columns, mostly what you have in your Excel spreadsheets and then your CSV formats and the rest. And so based on request and then also means to advance this, we have addressed the same consecutive wet or dry day computation functions and then applying it to multi-dimensional data sets this time. And specifically, we are looking at it being used or being applied on a NetCDF data set. All right, so that's what we'll be doing today. If you're new here, don't forget to subscribe and be part of the family. And we all want to grow together. So let's learn, let's be good together. All right, so to kick it started, we import our XArray, which is to allow us read and then manipulate our multi-dimensional data. That's a NetCDF format. And then we also import the pandas, which I'll be using this specifically for a daytime creation and also make use of the NumPy for other functionalities as we look through. All right, so again, I'll upload this onto the GitHub page so those who would need it can actually have a look at it and then probably use it. And so yes, so we import our XArray, import our pandas, and then import NumPy. And then now we come to the consecutive wet or dry day function. And the earlier one we wrote made use of the while loop. And so this is an enhancement, and this actually really faster because this makes use of the for loop. So we build a function called consecutive on a data set on the threshold for either dry or wet, and then the type where input here can be either CDD or CWD depending on what you are computing. And so we have a counter, we initialize a count to 0, and then we open up a blank list for appending certain outputs to. Then now we enumerate the data set, okay, so by I and J, where I represents the um, various positions and then the J represents the data itself. And then wherever the consecutive function to be applied is set as CWD, then it means what we are doing is that we will loop through the DA, that's the data set, and wherever the data set is greater than the threshold, it means we increase the count, which we've initialized to 0. So it means this will be increasing. And then for a data point where this function is not true, the count is re-initialized to 0. And then we save this back to the count. And this to help us, number out consecutive periods and then break through whenever that condition is not met. And if it's CDD, then it means when this is less than the threshold. So in actual sense, CWD means greater or equal to the threshold. Where in this case the threshold is 1, where 1 is for rainy day, so greater or equal to 1, and then less than 1 being the dry day, which we'll be using for the CDD. And then from there we append the count at every time step to the overall counter, and when we are done we return the maximum overall counter, which would be the maximum spell for the data set. Okay, and so next we now apply this function to the multi-dimensional data set. So in this case I'm making use of a rainfall data set, and I open the data set, which is rainfall.nc, using the xarray open dataset function, and then I call the variable pr, and this data actually is in a unit of kilogram per that's kilogram per meter square per second, so I need to convert this into millimeters, which is then by multiplying a factor of 86400 to convert that. And then the next phase is to pull out the time and then the years. Now what I do in here Let me run this up here so we get to see clearly what it is. So by calling out the data.time, we get to see the time component of our data set. And then if I need the years of this data set, it means I make use of my square bracket approach and call the time.year as a string. And that produces only the years. Yes, now if I pick the values of the time.years, I get the values as an array, which I can change into a set so that there are no duplicates. So by changing this to a set, there are no duplicates, and then I later pass this back as a list so that I can still have the same list approach, but this time without duplicates. And so that's typically what we've done in the first part, because we want to make use of the years and then compute the CWD or CDD on a yearly basis, depending on our data set. All right, so that's for the first two parts. And then the next item is to then look at the size of, uh, pick the data shape, and then we make a list out of that. We term that as, respective sizes. And this, because the data set is based on time, longitude, latitude, will give us a time, longitude, latitude um, shape. So, you can always test it out here. Okay. And because I would be computing the CWD, CDD on specific for the various years, I wouldn't need all the time steps. Rather, I'll need the length of this first part, which is the time, to be equal to the number of years. So I pick the years we created without duplicates and then find the length of that. So the length of the years alone is being passed into the first position of the shape. All right. So that in its place we would have something like this: 165 by 12 by 6. Okay. And then after that, we create zeros that are based on the size. All right. So we just create um, an array of zeros for the same size as CWD and then as CDD. And then now we loop through the years. We start looping through the years. So if I start with maybe the first year, maybe 1850, it means we want to just subset that data and then perform the CDD or CWD for that period alone. All right. So for I or year, for I comma year in enumerate years, meaning I would be the position and then the YR will be for that particular year. And then we now loop through the second shape. So looking at this, we have the second one being the latitude. So first is the time, the latitude, and then the longitude. So whilst we are looping through the time component up here, which is the years, we then create also another loop for the latitude, and then in it another loop for the longitude, so that we pick individual grids and then their time series. Okay, and then we pick our CWD, which is full of zeros. We pick the position that matches that of our position of the year, and then that of the position of the A, which is the latitude, and then the B, which is the longitude. And then we perform the function. We call the function on our data set. Now in this case, our data set would be calling the data, and we select the time, which is equal to the year we are now computing, right? And then when we have that, we pick the whole time series, okay, for the points that correspond to A and B, which is the latitude and longitude of interest, which is that grid point. Okay, so we'll have the time series, which is for a particular year, and we extract the values, okay, because our function is based on, again, more ASCII sort of computation. And then we pass in our threshold and then what we want to estimate. So we do that for the CWD in the first part and do same for the CDD in the second part. So this is the component that takes a bit of time. All right. And then once we are done, we'll have an array of CWD and then CDD, which is made up of the consecutive wet days and consecutive dry days for individual points and then individual periods. All right. And so once we have that, now we are going to change this array into a data array. So it's easy to now manipulate that with X array and easily visualize. So we make use of our xr.data array, which is a creation of a data array, and we indicate that our data is, in this case, a CWD, all right? And then we pick the dimensions, so the original dimensions of the data. So data.dims to give us the dimension. We create that as a list and pass that as the dimensions again into the new data array. And then the coordinates, which is slightly different from dimensions. Coordinates actually are the values for the values along each dimension. So now we pass in the values for the longitude, the values for the latitude, and then we pass in the values for the time because we had the time dimension also. And this is where we use the pandas to date time subfunction, and then we transform the years here into a date time by passing in a format because our formats for the years were just yearly format. So percentage y will convert these into um, yearly time steps or into date times with just the year components. All right. So let me just go back again and we look at our CWD, and this how it is. So it's computed for all the periods as an array. All right. And so once we've done this part, we also want to name our variable. So the variable in this case is the CWD, which is a consecutive word day, and then we give extra attributes by creating a dictionary where we pass in the attributes. So description to be the what the data really contains. Okay, so consecutive word days in full, and the name here is just a variable name in the short form, and then we give the units. Now CWD is based on consecutive number of days, so the units are in days. All right, and then we save this data array as a new underscore CWD. We can do same for the CDD, making use of the CDD output, and then we run this part, and this changes our array up here into more of a data array. So now if I call my new underscore CWD, it comes out as a data array with a variable CWD and then time, okay, equal to the number of years, all right, and then the latitude and longitudes matching up. And that's how simply you compute your CWD or your CDD for a multi-dimensional data set. Now with this, it's easy to visualize any point. So let's say I call my new underscore CWD at point 0, okay, which is this. Okay, so I call the first time and then I can just simply plot, and yes, and that should be the output right here. Okay. Um, Also bear in mind, I mean, we had our time components in here, so I could equally call by the time. So I have my new underscore CWD dot cell to select, and then the time equal to, let's say 2013. Okay, so I select the time and just visualize that, and we expect the output to be produced, right? So that's the output down here for the 2013 consecutive word days. All right, and we can see the smooth transitioning or the maximums in the lower latitudes and then a reduction into the higher latitudes. All right, so this is what we visualize here by also importing the Catopy to be able to generate our um, projections, making use of our projections, and then also generating the boundaries. And then we import our matplotlib.pyplot just for the visualization features we would need. And then I think we already have a tutorial on this aspect which I'll add into the description box, and you can have a look at it if you need more clarification on the visualization approach done here. Okay, so in simple terms, we pass our fig and then the axis to a plt.subplot, set the number of columns, define the fig size, and then because we want this to be a geographical plot, we set a projection in here from the Catopy as a quarks under the um, subplot, and then we call our new CDD, right? Average it over the time, and then we plot, and then we set the color map as red, blue, reverse form, okay? And then now we pass in the AX because axis here is based on the column, so that means we have two columns, and this will be treated as an array. So I can call axis 0 and then assign that to the AX, and that will be the one on the left hand side. And then I set my vmin in here. Now, since this axis has been dealt with as a Katupai geographic map. We can equally add coastlines and then add other features, and then also set our extent. And that's typically what we have down here. We perform the same for the CWD. Well, in this case, our axis will be axis 1 because there's a zeroth axis and then the axis ID 1. All right, and that's simply how to produce your CWD and CDD from the multi-dimensional data set, or in this case a netcdf file, and you can also apply that to other multi-dimensional data sets. All right, so this is just um, simply addressing what we've been tackling so far on consecutive wet and dry days, and this time looking at it being applied to multi-dimensional data sets. All right, okay, so that's by way of today's session. And then if you are new here, like we always say, don't forget to be part of the family, subscribe, hit the notification bell, and then join us. And whenever we post something new, you would find that for your consumption. And also, I mean, it's a whole community, so get others involved, get others to also join in the whole learning phase, and let's all grow together. Don't forget to leave a comment, or if you have any question, leave it in the comment section, and then the team would address it. And also give us a like, and hope to see you next time in another video. Bye bye.